Hey everyone, so we're in the Khan Academy pre-algebra class. Scrolling down to unit 6, variables and expressions. So I'm going to go ahead and do the unit test today. So go all the way down and let's go ahead and take the unit test. All right, so we got 12 questions, 12 to 24 minutes. Alrighty. So this one says, evaluate the expression 2 times 5 to the x for x equals 2. So x is 2, and we have 2 times 5 to the x power. So with order of operations, it's my PEMDAS, so I'm going to do my exponents are kind of coming early in this process. Thus, parentheses, exponents, multiply and divide left to right, add and subtract left to right. So I want to make sure I do 5 to the x power first before I multiply the 2 and the 5. So 5 to the x power is going to be 5 to the second power. That is 5 times 5, which is 25. So this here, 5 to the x power is 5 to the second power, which is 25. So we're going to have 25 times 2, and that should give us 50 as an answer there. So I think I like 50. Very nice. All right. So this one says, apply the distributive property to factor out the greatest common factor. So we're looking here at 24j minus 16, and I'm trying to pull out the greatest common factor. I could try to pull out the variable j, but 16 doesn't have a j. I'm just going to pull out the greatest number that I can, and I think 8 is going to be the greatest factor that can come out of 24 and 16. So the way I think about this is I'm like undistributing. I'm pulling out the 8. So if I did that, I would be left with 8 times. I'll do it over here. So I'd be left with 8 times. 8 times what is 24j? That's going to be 3j. 8 times what is negative 16? That's going to be negative 2. It's a little wide. So I'm going to pull out the 8, and I'm going to be left with 8 times 3j minus 2. If I multiplied the 8 back in, I would have the same thing I started with, which is 24j minus 16. So they're mathematically the same thing. I'm just applying the distributive property and pulling out the greatest common factor. 3j minus 2. So like that. Very nice. All right, let's take a look here. So this one says combine the like terms to create an equivalent expression. So I'm going to combine like terms. All my similar variables will be combined. There's only one x. There's only one y. And I can't combine those since they're not the same variable. All I can really combine in this example is the negative 1 and the positive 4. So negative 1 plus 4 equals 3. So all I can do to simplify this is I can combine the negative 1 and the 4 to give me 3. So all I can do to simplify, like I said, I'm going to have 8x. I'm going to have minus 2y. We've agreed on that. Those can't combine. And the negative 1 and the positive 4 come together to a plus 3. So that's all the simplifying I can do here to combine like terms. My x's are together, my y's are together, my constants are together as well. All right, this one says the expression 62.4d minus 210 gives the number of Indian rupees you receive when you exchange D dollars at the local currency exchange. How many Indian rupees will you receive when you exchange $13? So the amount of rupees equals 62.4 times the number of dollars minus 210. So it's asking how many rupees will we get if we're exchanging $13. So I'm going to do 62.4, multiply that by 13, since that will represent the number of dollars, and then minus 210. So I just need to figure out what's 62.4 times 13. So let's do that here. So 62.4 times 13, and then we'll subtract 210. So it's going to give me 601.2 Indian rupees, I hope. 601.2 Indian rupees. Very nice. All right. This question says factor 72y plus 108z to identify the equivalent expressions. Okay, so these are all kind of different factored versions. There's 4 versions, and I got to figure out which ones are equivalent. So I'm actually not even going to factor it. I'm just going to distribute my answer choices. So for A, I'm going to check, does this match 72y plus 108z? 9 times 7 is 63, so I'm going to get 63y. So I can already cross out this one here since it doesn't equal 72. So let's try the next one. 36, excuse me. 36 times 2 is 72, so that's 72y. And then 36 times 3 is 30, 60, 90. 90 plus 18 is 108, so plus 108z. So I like that. So 36 times 3 does come out to 108. So I'll check B as one of my choices. 6 times 18, that's 60 plus 48. That's not going to be right. It's going to come out too high. 12 times 6, that is 72. And then 12 times 9 is 90 plus 18, which is 108. So it looks like B and D. If we distribute, we're going to end up with 72y plus 108z, and the others we will not. So there you go. All right, this one says distribute to create an equivalent expression with the fewest symbols possible. So I'm going to distribute, and it mentions the fewest symbols possible. We'll see how that plays in. So 6 times 5x is 30x. And 6 times -3 is -18. I think that this is our answer, fewest symbols possible. There's no way to combine these. The 30x and the 18 and the -18. They're not like terms. There you go. This question says, Sebastian has 12 more trophies than Megan. Megan has T trophies. How many trophies does Sebastian have? Well, if Megan has T and Sebastian has 12 more than that, I would say that it's T plus 12. So it's whatever Megan has is T, and then we'll add 12 to that. That's how many Sebastian has. Sounds good. Good job, Sebastian. All right, this one says, Kyrie and Jayla were trying to describe parts of an expression. Good for them. So they've got this 5p plus 3 times p plus 1. Jayla says the entire expression is the sum of 2 terms. So these 2 terms are being multiplied. This is actually one term. I think you can think of it as one term. Kyrie said the entire expression is the product of 4 factors. So we'd be multiplying 4 things together. My goodness, this is kind of, to me, looks like one term with 2 factors. This is actually kind of tricky. If we multiply these together, that might help us. We get 5p squared. You'd get a p term. You'd get a plus 5 and a plus 3, so plus 8p and a plus 3. So if you kind of rewrite it, you can think of it as kind of 3 separate terms that are being added. This one has 2 factors. So I'm actually leaning towards none of these are correct. 5 terms being summed. There are not 5 terms being summed. There's a term here, another term here. This is the sum of 2 terms. This is also the sum of 2 terms. And the 4 factors, that would be something like, 5x, y, z. This is 4 factors all being multiplied. Since factors are things that are being multiplied together. I'm going to think these are both incorrect. So it's tough to like assess or teach it in this way because they're just totally wrong. So it's tough to give a non-example, but I would recommend looking through the solutions here and doing some more research there if you're struggling on terms and factors. This was the trickiest thing for me as well, I will say. All right. This says, write an expression to represent 7 minus the product of 3 and x. So I'm going to take the product of 3 and x, and it's 7 minus that. So it's 7 minus the product of 3 and x. So I think it's going to like that. So I'm just kind of like taking the English and writing it in math language. 7 minus 3x, 7 minus the product of 3 and x. So I think that's it. This says evaluate 0.3y plus y over z when y equals 10 and z equals 5. Well, that's nice. So all that I need to do is take the y's. I have 2 y's, and I'm going to put in 10. So it's 0.3 times 10. That will come out to 3. Plus 10 over z, where z is 5. So like we said, 0.3 times 10, that comes out to 3. 30% of 10 is 3. Plus 10 over 5 is 2. So this comes out to a nice clean cinco, a nice clean 5 there. Very nice. All right, this one says asks which expressions are equivalent to 3x plus 3, I'm gonna get rid of that yellow, plus 3 times x plus y. So if I distribute the 3, I have a 3x here, then 3 times x is another 3x, and then plus a 3y. So all together, I'm gonna have 6 x's, not just 3 and 3. I can combine them to 6, and then plus 3y. So I'm looking for answers that equal 6x plus 3y. So A is going to work. C is totally different. This is 3xy. There's like one term there. It's an xy term. That's different than 6x plus 3y. Here I can distribute. So I'm going to get 3 times x is 3x plus 3x plus 3y. I think that's going to come out the same. These combined give you 6x. So 6x plus 3y. So I think A and B together are going to be good for us here. So let's see if it likes it. Very nice. All right. Last question. What happens to the value of the expression 5 over x plus 5 as x decreases? I'm not going to read the rest of this. As it decreases. So if I put in a big number for x, I'm going to get 5 over, let's say, some big number. I don't even need to pick that big of a number to make this kind of small. But let's pick the number 10. That's not even that big. Plus 5. But we'll call 10 the big number. So if 10 is the big number, when x is 10, what do we get? 5 over 10 is a half, plus 5, so that's 5.5. So when we put in 10, we get the number 5.5. Well, what happens if we decrease? What happens if we decrease that? So let's do x is 1. So that's going to give us 5 over 1 now instead of 10, plus 5. So that's going to give us 5 over 1 is 5, plus 5 is 10. So it looks like as x went down, the value of this expression actually went up because it went from 5.5 to 10. So I think as x gets smaller, it seems to me like the number that we're going to get is going to keep getting bigger. It increases. Very nice. All right. Hope that helps and have fun.